Welcome back everybody, Gary Simmons here of the Game Institute, and this is lesson 11 of the Dead Earth game development series. Now in the last lesson we sourced ourselves some pretty nice zombie animations to get started with and some cool zombie models all from Mixamo.com, and we dragged and dropped them into our project so that they've been roughly imported, but they haven't really been set up properly yet. And let me show you what I mean. So if I go to my project view and drill down into my Dead Earth folder, you will recall that we stored all of our animations in this animations folder in a subfolder called Mixamo Animations. So if I choose, for example, Zombie Walk, and you can see that when I select the animation in the import inspector, what we want to do is we want to select the animations tab. That's allowing us to see the animation data in that file. And by default, this is playing the Jill model. And we can change the model at any time by going to the models folder, the Mixamo characters folder, and we can drag in one of our characters. So if we drag Jill in, this is what we'd see. And you can see here that the walking animation plays perfectly as we would expect. Let's try another character. So let's drag over Derek. Remember, this is still the walk animation, but we're just previewing it with a different character model. And you can see that, hey, wow, that model animation works on Derek too. But let's drag over another one now, such as this Zombie 1 model here. You can already see by the fact that it snaps straight to T-pose. If we press play, the animation is not compatible with this model at all. In fact, these animations have really been tailored for the Jill model, because the Jill model was the model that we had selected at Mixamo when we were selecting our animations. And you will recall actually that when we downloaded the animations, not only were the animations all called Jill at Walking 1, things like that, which is a clear indicator that these are animations compatible with the Jill model, but they also bundled with that the Jill model as well, even though we didn't ask for it. And we're going to see why that is important in a moment. In fact, the sheer fact that this animation plays with Derek is actually just a bit of luck. And there's a few of these models that it will work with, like I think it will work with White Clown as well. And that's not really surprising, because probably most of these models that were made at Mixamo were probably made by the same artists using the same skeletal rig, in which case the animations that we make for that rig are going to work on all characters that use that rig. But if we look at another zombie, such as Zombie 1, that although a Mixamo asset may have been designed by somebody else using a different rig, we can see that the animation data is looking to animate bones in a hierarchy and just cannot find the bones with the right name, and therefore has no idea how to animate this model. And in fact, this has always traditionally been a really big problem. If you go onto the asset store historically and bought, for example, a model of a skeleton that came with 14 animations, the person that made that skeletal bone hierarchy would have called those bones very specific names, perhaps names that he likes working with. And all of the animation data that contains keyframes are going to be looking for bones in a hierarchy with those specific names. So the minute we try to play that animation on a different character made by somebody else using a different bone layout, even if the layout's the same, just using different names for the bones in the hierarchy, then the animation data and Unity's animation system is not going to have any idea how to animate that hierarchy. It's not going to know when it sees a keyframe for a bone called left leg. If there isn't a bone called left leg because someone might have called it just left lower leg or something like that, it's not going to animate. And this is a real problem, and it's one of the things that has been fixed with such an excellent system in Unity 4 with their animation system Mechanim. And these allow us to retarget animations. In other words, take an animation that was designed for Jill and have it work on all of our bipedal characters, what Unity calls humanoid characters. So in order to understand how to configure these import settings for our animations and our models, we need to first understand what a skinned character actually is, what a bone hierarchy is. So that's what we're going to do first, and then we'll come back and we'll look at how we can address the issues that I've discussed. In modern computer games, characters are modeled and animated using a technique called skinning. To use this technique, modelers using tools such as 3ds Max, Maya or Blender first create a regular mesh of their character. Then a bone hierarchy representing the shape and joints of a bipedal skeleton is then scaled and repositioned to fit inside the mesh. Now, a mesh used for this purpose is often referred to as being a skin, because it can be thought of as being like a skin of polygons surrounding a skeletal bone hierarchy. It is often common for the mesh to be created in a T-pose, which allows for easier positioning of the skeleton inside it. At this point, a process is performed to attach the vertices of the mesh to the skeleton, a process referred to as rigging or skinning the character. Now, in order to understand the skinning technique and what a bone hierarchy is, let us first examine a very simple example of the top half of a character with body parts that I've made from Unity primitives, all connected to a transform hierarchy so that the body parts can be individually rotated. First, I added an empty game object and I called it hips, and then added a cube primitive to represent the pelvis of the character. Then I added an empty child game object and offset it from its parent to position it where I thought the chest would approximately be. I then renamed this game object chest and then added another cube primitive to it to represent the chest area. As the chest is a child transform of the hips, it will move and rotate along with the parent whenever I alter the rotation of its parent. But as a child, I can still rotate it freely of its parent. I then thought, what children should spout from the chest? Well, what about the head? So I added an empty child game object to the chest. Then I offset it upwards to the position that I thought the head would approximately be and added a sphere primitive to represent the head. Now, rotating the root transform, the hips, rotates all of its children, the chest and the head. Rotating the chest just rotates the chest and the head, but the head too can be freely rotated from the chest. So what other body parts would need to be connected to the chest? Well, what about the arms? So I added two empty game objects for the left and right shoulder joints and moved them into position. I added no primitives to these, as these are just going to be used to create rotational points used to rotate the children that I will attach to them, the actual arms. To both the left and right shoulder joints, I then added two more children to represent the upper arms. I added a capsule primitive to each of these and offset them from their parent shoulder joints to correctly represent the location of the upper arms. Rotating a shoulder joint now rotates its child, the upper arm, without affecting the rest of the model, but rotating the chest rotates all of its children, the arms and the head. Next, I added two more child game objects, one to each of the upper arm game objects, and I named them left and right elbow joint respectively. Much like the shoulder joints, these will be empty game objects that provide nothing more than a point of rotation for its child game objects, which will be the lower arm sections, which you can see I've added here. With these in place, we can now move the entire arm by animating just the shoulder joint, or we can move just the lower arm by rotating only the elbow joint. Rotating the chest rotates all sections connected to the chest, both arms and the head. Of course, if representing a real character, we would also have to create upper and lower leg sections that would be connected as children of the hips. Now, however primitive this may have been constructed, what you're looking at here is a skeletal hierarchy. Now, when we see the fancy tools that are exposed by 3D packages, which allow us to create skeletons and place them in meshes, and we hear the scary terms like bones and bone hierarchy, we are really just referring to a hierarchy of transforms. That's all it is. A bone is really just a transform in a connected hierarchy that represents a position, a rotation, and a scale within that hierarchy. Although we will discuss animation in more detail in a moment, when we load in character animations, these animations simply contain keyframes on a timeline, where each keyframe describes the rotation, the position, and or scale of a single transform in that hierarchy at the given time. The modeler, when creating this animation, simply steps through a timeline, positions the character in a pose, usually by rotating the bones, much like we did here, and then records the state of the changed bone rotation to keyframes on the animation's timeline. When the animation timeline is played back at runtime, the keyframes are fetched at the appropriate time, and a single keyframe describes the name of a bone in the hierarchy and the position and the rotation that that bone should be set to at this specific time in the timeline. Now, in order to calculate the position of bones that are between keyframes, the positions are interpolated using the keyframes that bound the current playback time. Tools such as 3ds Max make posing the skeleton delightfully easy by implying inverse kinematics. In short, if you wanted to have the skeleton's hand reach up and open a door, you would simply grab the hand in the editor and move it into the position on the door handle. And the inverse kinematics would resolve the rotations of all the connected bones to keep the skeletal structure intact. If we simply move the hand without this system in place, then the hand would be positioned on the door handle, but the forearm would still be down by the character's side, and there would be a massive gap between them. There would be no connectivity. Inverse kinematic systems such as those employed by 3ds Max would not allow this to happen. As you move the hand, it would automatically rotate the chest, the shoulder joint, the upper arm and the forearm to keep it connected to the hand. And this makes posing characters much quicker, and is why modelers use modeling apps such as 3ds Max, Maya or Blender for creating their skeletal animations. Now in this example, each transform, in other words, each bone in our skeleton, has a unique and separate mesh attached to it, so that when the transform is updated, either directly or through the animation of one of its parent transforms, the attached mesh has its position updated too. It doesn't look too good though, does it? Not so long ago, well, at least if you're my age, this was how 3D characters were animated in 3D games. Here on the screen now you can see some gameplay of the retro PC 3D fighting game Virtua Fighter 2. Each bone in the hierarchy has a separate mesh attached to it, which causes hard and visually grating intersections at the joints, especially visible on knee, elbow and shoulder joints. Now this type of distortion was commonplace in games of the 90s until the skinning technique was introduced. I think the first game I played where I noticed skinning being used was Half-Life 1 by Valve Software. Now although it looks rather primitive by today's standards, the characters moving without the obvious intersections at the joints literally blew my mind. How was this crazy dark mojo being accomplished? Now if you really want to know how skinning works at a low level, then I would encourage you to check out my old DirectX 9 graphics programming course here at the Game Institute. There is an entire chapter on skinning along with source code examples. However, we don't need to get too distracted in this lesson, so I'm just going to briefly describe the process, if somewhat euphemistically. So if I disable my primitive character and add a simple cube to the scene, we know that the cube has a single position in the world. That's described by its transform. The vertices that describe the corner points of the cube are essentially described as offsets from this position. When we move the transform, the vertices of the cube move along with it, and thus the cube itself. If we were to imagine this as a skeletal hierarchy then, we could say that the cube had a single bone at its center point, its transform. If I enable my primitive half character again, we can see the hierarchy is made up of multiple bones, but each body part is a separate mesh, each attached to only one immediate parent bone. The vertices of the lower left arm capsule, for example, are described as offsets from the lower left arm transform, a single bone. While moving any parent in the hierarchy propagates those changes down to its children, once the hierarchies have been updated, the positions of the vertices of the left lower arm capsule primitive are still just defined relative to only one bone, the lower left arm transform. Skinning is the technique of surrounding the entire bone hierarchy with a single mesh and making connections between which bone affects which vertices in the mesh in an attempt to allow the mesh to controllably deform. Usually there is a maximum limit of 4 bone influences per vertex, and the modeler, using the rigging tools in 3ds Max, Maya or Blender, can literally paint in which vertices should be affected by the movement of which bones and the weight of those influences. The end result after much tweaking is a mesh that deforms in a desirable way when the skeleton is animated. To use a somewhat simplistic example, imagine an animation that has the character twisting its chest to the left while keeping its hips facing fully forward. Now, the vertices near the chest bone would rotate fully with the chest, as they may have been set up to only be influenced by that one chest bone. Now, the vertices near the hips, if set up to only be influenced by the hip bone, would not rotate at all. Now, the vertices in the stomach area of the mesh, halfway between the hips and the chest bones, would be influenced to some degree by both bones, and therefore they would rotate partially along with the chest bone, but not fully. Vertices that were equidistant with respect to the chest and hip bones, and thus painted to be weighted equally by both bones, would rotate only half the full rotation of the chest. Vertices nearer the chest bone would be influenced by the chest bone more strongly, and rotated to a greater extent, while vertices nearer the hips would be rotated to a lesser extent. We would see, during an animation like this, the entire torso of the character twist to a greater degree as we scan up the body towards the chest, giving a smooth and seamless deformation. So when we import a character mesh into Unity, we are importing a bone hierarchy and a mesh, its skin, with additional data that contains which vertices are influenced by which bones in that hierarchy. And because a special vertex transformation technique is required to render such meshes, taking the vertex weights and multiple bones per vertex into account, that is why when we add a skinned mesh to our scene, the mesh itself has a skinned mesh renderer component instead of a regular mesh renderer component. So we're now in a better situation to understand why we were having a problem with some of our animations working with some of our models. Now, we know that our animations were made to be compatible with the Jill bone hierarchy. So let's drag a copy of Jill into the scene. So I'm going to go into the models folder, the Mix Mode Characters folder, and I'm going to drag an instance of Jill into the scene. Now, if I go to the hierarchy view and I open up Jill, I can see that she has two sub-hierarchies. One of them, called Jill High-Res Meshes, is a sub-hierarchy that contains all of the meshes, most of which are skinned meshes, which are skinned to Jill's bone hierarchy. If I open up the game object called Hips, this is the actual bone hierarchy. The root bone, is called Hips. And if we just examine its immediate children, we can see it has a left up leg child, a right up leg child, and a spine child. These, of course, all have children underneath them to fill out the other parts of the skeleton. But let's just concentrate on these three for now. Now, we also saw earlier on that when we selected one of Jill's animations, such as the zombie walk, and we dragged the Derek model into the animation preview window, we could see that that animation had no trouble playing on the bone hierarchy used by Derek. Now, we already have an instance of Derek in the scene, so let's have a look at its bone hierarchy. And once again, I'm only going to concentrate on the immediate children, but look, not only is it arranged exactly the same as Jill's, it has exactly the same names for those bones. So we've got hips, hips, left up leg, right up leg, spine, spine. Therefore, that animation for Jill is going to work exactly the same on Derek's bone hierarchy because they use exactly the same bone layouts with exactly the same name. When Unity comes to play those animations and is reading the keyframe data, it's going to look for a game object in its bone hierarchy with a very precise name, and in this case the names of both bone hierarchy matches, and therefore those animations will play on any character that has the identical bone hierarchy to Jill, and Derek is one of those such models. So now let's open up one of the models that the animation didn't work on out of the box. So I'm going to drag an instance of the Zombie 1 model into the scene. There it is. So let's now go to the hierarchy view and let's open up its sub-hierarchy. Now we can see that it has a skin mesh called Zombie Geo, short for Zombie Geography, and we can see in the inspector it has the skin mesh renderer. Now its second game object, called Hips, is the root bone of its hierarchy. And you can see that it's laid out exactly the same as Jill's hierarchy. It's probably exactly the same rig being used, but notice the different names. Instead of just hips as the root bone, it's got zombie : hips. Instead of left up leg, it's got zombie left up leg, and zombie right up leg, and zombie spine. So although these bones are exactly the same and arranged in exactly the same order, and it probably is the same skeleton being used, they've been named differently. Therefore, when an animation for Jill's rig plays and it searches the hierarchy for a bone called hips, or a bone called left up leg, or a bone called spine, it's not going to find them. There aren't any bones just called spine. It's called zombie spine. And that's why, without Unity's retargeting solution that was only introduced in Unity 4, you were typically stuck if you bought a animated character off the asset store. Although those animations worked with that character, they wouldn't work with any other character unless by some fluke the other character that you wish to use with those animations used exactly the same bone hierarchy with exactly the same names. So before we continue, let's talk a little bit about the variety of FBX files that you may encounter when you're importing character models or animations into Unity in the FBX format, because several varieties exist. For example, you might encounter an FBX file, much like the ones we've downloaded from Mixamo of just our characters, where they don't contain any animation data, they just contain the skinned mesh itself and the bone hierarchy that is used by that skinned mesh. And then you might encounter FBX files much like the animations that we've imported from Unity that don't have a mesh embedded in it, but they just have the animation data itself, and for each animation Unity will create an animation clip asset from it, and you'll see later how these animation clips can then be dragged and dropped into an animation controller and used to build a complex state machine hierarchy. But these animations also contain a copy of the bone hierarchy, because the bone hierarchy also needs to be in the animation file, because it's that bone hierarchy that the keyframes in the animation clips are referencing. So you'll notice that for each of our animations there will be a separate copy of the bone hierarchy, the root bone, which is shown here, called hips. And then you will find FBX files, and this is quite common if you purchase assets off the asset store, where you may see a character for sale and it says that this character comes with 15 animations. And when you import an FBX file like that, the FBX file will contain the skinned mesh, the bone hierarchy, and 15 separate animation clips. And you'll see when you import a file like this, I haven't got one to hand at the moment, but we'll see some later, that Unity will create a separate animation clip asset, that's this thing here with the little play button icon, for every animation in that file. And if you were to look at one of those FBX files in the project view, you'd see it would contain the mesh, the bone hierarchy, in this case hips, and all of the animation clips. So in that example we would see 15 different assets with this little play button icon. Now if we go back to our characters folder and we select, let's say, our zombie character, we know that these characters were downloaded from Mixamo without animations. They should just contain the mesh and the bone hierarchy. But if I open it up in the project view, you'll see it does contain the bone hierarchy, and it contains the mesh called Zombie Geo, and this second entry called Zombie Geo is just the mesh data for that, so you can think of these as being one item. You'll also notice though that there is an asset that Unity has created called an avatar. And you'll notice that all of the characters that we've imported and all of our animations have had this avatar created for it. Forget about it for now. In just a few moments time we're going to talk in detail about avatars. But also notice that in this zombie file here that should just contain a mesh and a bone hierarchy, we also have an animation clip generated. Now if we play that animation clip, it's just an animation that seems to contain a single frame of that character in its reference pose, the T pose. And I'm going to be honest with you, I don't know whether this is something that Mixamo has done or something that Unity does if you choose to import animations on an FBX file that doesn't have any animations. For example, we know that this zombie one file shouldn't have any animations in it. But if we select it and go to the Animations tab in the Import Inspector, I've got import animation ticked, which is the default. And you can see that if I untick that and click apply, and when I do that, keep your eyes down here on this little Mixamo.com animation clip that was created for us here, you'll notice it disappears, because we've told Unity that we don't want to import any animations for this FBX file. So know that animation data has been discarded and an animation clip hasn't been created. My point being here is I don't know whether the fact that that single frame animation clip is being created is something that Mixamo just embed in all of their character files. Or maybe this is something that Unity does when you choose import animation on a model that doesn't have any animations in it. Perhaps Unity just analyzes the reference pose of the model and then just creates an animation clip with a single frame of it in that pose. Either way, it doesn't really matter, but I'm just drawing your attention to this because if you open up all of these files, you'll notice that they all have this same sort of default animation clip created for it of the model in its kind of reference pose. And once again, just to remind you, if we choose one of our animation files and we open that up, you'll see that it has the walking animation clip, which is right, that's what we should have. Let me just drag Jill into the scene for a moment so the animation will actually work on it. There you go. So if I go back to this walking animation clip here, we can see that this file contains the bone hierarchy, which is needed by the animation clip because the keyframes reference those bones by name. And Unity has also sucked out all of the animation data and it's created an animation clip asset for it called walking. And we can play that and see what it looks like. And we can also see it's created this avatar, which we're going to talk about very, very shortly. Okay, so that's two varieties that we're using so far of how FBXs can come into Unity. You'll also see how there's another variety, and we'll see this later as well, where when you import an FBX file, it may contain multiple animations, but all of those animations may have been given to you as a single animation timeline. And when this is the case, what you'll generally see is instead of having all of the separate clip assets generated for you, such as walking, running, drinking, sitting, whatever, it will be up to you to search through the timeline and find the various frames where each animation begins and then adjust the timeline cursors like this. And then what you can do is you can click the plus sign here and you can create an animation clip from just that subsection of the animation's timeline. Like I said though, you only have to use this feature if you import an FBX file where you have a single animation that contains all of the sub animations in a single timeline. And we'll probably see some of those a little bit later on as we bring in more assets into Dead Earth. So we need to be prepared to work with all of those. But I'm just making you aware of the different ways that FBX files can come into Unity. Okay, so let's go back to our character models now, and let's try and figure out how we can get our animations to play on all of our models. With Unity 4, Unity Technologies introduced an entirely new animation system called Mechanim. Now, one of the wonderful things about Mechanim was the ability to be able to easily, and in most cases automatically, retarget humanoid animations to work on any humanoid model. Honestly, before this possibility was opened up to me, the chances of me making a first-person shooter game like Dead Earth were next to none, unless I had a team of animators that could either create all the custom animations that I needed for all the various character models that I purchased, or I would need to have a team of animators re-rig any of the models I bought with identical bone hierarchies that matched my library of animations. Unity has a specialized workflow for humanoid models and humanoid animations that allows for animations designed to animate one humanoid bone hierarchy to be able to talk to and animate a character with an entirely different humanoid bone hierarchy. This communication is accomplished with the use of humanoid avatars. For every humanoid animation or character model that we import, an avatar is created for it, which analyzes the bone hierarchy in the file, which can be either an animation file or a character mesh file, and tries to identify which humanoid body parts in the avatar system, such as upper left arm, hips, lower left leg, maps to which transform in the associated bone hierarchy. Even if Unity fails to auto-map the bone hierarchy in the file to body parts in the humanoid avatar system, we still have the ability to manually set up the avatar, assigning bones in the hierarchy to body parts in the avatar system by simply dragging and dropping transforms into slots, and we're going to see all this in action in a moment. So for an animation clip, those bone names referenced by the keyframes are assigned to body parts in the animation's avatar. So a bone called, for example, Gary's monster upper left arm in the animation file would simply be mapped to the upper left arm body part of the animation clip's avatar. The animation's avatar now knows that irrespective of what the original bone name was, the upper left arm in the target bone hierarchy now has to be updated. Now, the target bone hierarchy, in this example the skeleton of the character mesh that we wish to be animated in the scene, might have a completely different named upper left arm bone. Let's say it was called left arm upper 001. But that bone hierarchy too has had an avatar set up for it, where its bone, left arm upper 001, is simply mapped to the avatar's upper left arm body part. So while the animation cannot talk directly to the character's bone hierarchy, their avatars do talk the same language. So the animation clip in this example says update a bone called Gary's monster left arm. Now this is assigned to the upper left arm body part in the animation clip's avatar. This avatar then talks to the target avatar and says, hey, update the rotational position of your upper left arm body part. The target avatar, that's the avatar that's mapped to the character's bone hierarchy, looks up which bone has been assigned to its upper left arm body part and sees that it's a bone called left arm upper 001, and then relays that information onto the actual bone in the target hierarchy. So armed with this new knowledge, we're now ready to revisit our character files and our animation files and configure their import settings so that any of our animations will play on any of our humanoid characters. And that's going to involve revisiting each of these files individually and configuring their import settings so that Unity knows that they are humanoid skeletons and can create humanoid avatars for them. It's a pretty quick process though, or at least it normally is, so it's not so much of a big deal. So I think I'm going to start by configuring the character models first, and I'm going to start just at the very top with our UK dressed police zombie. Now when we select an FBX file, what we see in the inspector is the FBX import settings, and because an FBX file can contain a model, a rig is just another name for a skeleton or a bone hierarchy, and a series of one or more animations, that's why we get these three buttons across the top of the inspector so that we can step through each and configure how each is imported from the file and how Unity is to create assets from them. Now on the first tab, model, is where we get to choose all of the settings for importing the actual skinned mesh itself, and most of the time when importing characters you'll find that you can pretty much just leave these alone because the defaults are pretty good, and character models normally come in at the correct world scale, so you don't have to change the scale factor. Now of course if we find any characters along the way when developing Dead Earth where we do need to change these settings, I'll show what I do and we'll cover that then, but for now we'll just forget about this tab and we'll assume that the default settings for the actual mesh itself are okay. And we've also seen that when a FBX file contains animations, we also get a chance to configure those animations, to choose whether they can be imported or not. And if a timeline contains multiple animations, we also get a chance to, snip out the individual sections of the timeline that contains, for example, the walking animation or the running animation, and have Unity, by clicking this little plus sign, create separate animation clips from them, which we can then use in an animator controller. But we'll talk about all of that in a moment. So the rig button is the one we haven't really discussed about yet, and this is how the skeleton hierarchy in the file should be treated. And like I said, sometimes it's called a skeleton, sometimes it's called a rig, sometimes it's called an armature. So I suppose we should just call it rig from now on, as that's what Unity calls it. So we know that all of our character models and our animation files, every one of them contains a rig. So we need to configure this rig to be a humanoid rig. In other words, we need to let Unity know that we know that this is a character that basically has, 2 arms, 2 legs and a head, and therefore you should create a humanoid avatar for it. So to do that, I'm going to go to the rig button. Wasn't aware I'd changed anything, but I'll press apply. Oh yeah, I tweaked with the animation cursors, didn't I? And then on the rig button, you'll see that the very top of the settings there is this animation type, and by default all animations and all characters that are imported will be assigned to be a generic rig. And when we set it to generic, we're basically informing Unity that we don't wish this rig to be interpreted as a humanoid rig. It won't have a humanoid avatar created for it, and therefore any animations that have been configured as humanoid and therefore have their own humanoid avatars will not play on this rig. In fact, the only animations that will play on this rig will be animations that have an exactly matching rig. Now, we'll talk a little bit more about generic in a moment, but let's just step back a little bit and have a look at the other options that are here for the animation type. And we'll start at the top and work our way down, because you'll see that actually generic and humanoid are the only two choices that you have when you wish to use Mechanim. So the first option is to simply set it to none. And when we set it to none, we're basically saying to Unity, we just wish to grab the mesh really out of this file. We don't wish there to be any animations, because you can't have animations without a rig. So if there were any animation clips created from this file, and you'll remember we did have one called mixamo.com, it's now vanished. And if I go to the animations tab, you'll see that whereas before we had one animation that contained a single frame of the character in its T-pose, that's now gone too. Even though I've got import animation ticked, it's telling me that no animation data is available for this model. And this is because we've thrown away the rig and the animations and we're just bringing in the mesh. Now the second option is legacy, and I wouldn't recommend using this for any newer projects, because legacy is referring to the animation system that existed in Unity prior to Unity 4. It was in Unity 4 that Mechanim was introduced, an entirely new animation system that allowed us to use root motion and humanoid retargeting. But they kept the legacy animation system intact. So this is really for backwards compatibility. So you really don't want to be using the legacy import type on your animations or rigs in a modern Unity project, or you're going to miss out on all the lovely goodies that the Mechanim animation system provides us with, as well as the ability to retarget your animations and also to be able to utilize the root motion in the file, which means you're going to get a lot of foot sliding when you manually move your characters. So really that only leaves two options to choose from, which greatly simplifies our choices when importing a rig to use with Mechanim, and that is either generic or humanoid. And generic basically means anything that isn't humanoid. Now, although the generic rig is easier to configure, I'm going to start with the humanoid rig, firstly because that's what our characters and our animations need to be set to in order for us to be able to retarget them. And also because when we understand how the humanoid avatar works and configure it ourselves and see all the details, it's going to be a little bit easier to understand the generic avatar that's created for us behind the scenes when we import it as a generic rig. So what I'm going to do with this model here is I'm going to set its animation type to humanoid. I haven't clicked apply yet, so it hasn't actually been converted into a humanoid rig yet, but you'll notice that we have a setting here called avatar definition, and this is where we choose how we wish the humanoid avatar for this model to be created. We're going to leave this on create from this model, which basically means Unity is going to analyze the rig that's stored in this file, and it's going to try and match up all of the bones in the hierarchy with body parts in the avatar, and will automatically assign them to the avatar so everything just works out of the box. There's another option here called copy from other avatar. We're going to talk about that in a moment, but basically this just allows us to, instead of create a unique avatar for this model, just use one that already exists, that already has all the bones set up in the avatar definition. And we're actually going to have to use that in a minute, which I didn't plan on doing, but I'll talk about that in a moment. So we've got create from this model. We won't choose optimize game objects. We'll just leave everything at the default, and then I'm going to click the apply button, and now Unity will analyze my rig, create a humanoid avatar, and if you look down here in the project view, after I've clicked apply, you will see an avatar asset be created. So let's click apply, and there you go. We now have this avatar here. So as it stands at the moment, we have an avatar created, and the reason we know it's been successfully created is because you'll notice there's this little tick box here, and that tells us that Unity was able to find all the bones it expected to find, and it was correctly arranged in a T-pose. And you'll find that with all modern models and animations that you import, they will almost always be in the correct T-pose, and I've hardly had any difficulty bringing in animation rigs or character rigs with Mechanim. If they're humanoid, Mechanim recognizes it and normally automatically configures it. There have been one or two cases where I've had to go in and configure the avatar manually, and that's easy enough to do. Now, if the avatar isn't created successfully, instead of seeing a tick here, we'll see a cross, and we can click this configure button to open up the avatar definition, and we can tweak it manually or manually assign the bones. Likewise, even if you get a tick, it is possible that sometimes the animation might not look quite right, and that might be because the hierarchy inside the animation file has not been arranged perfectly as a T-pose. And because the animation data are specified relative to the original T-pose stance, you can have things where, let's say for example, instead of having the hierarchy in a T-pose, the legs were sort of opened up almost like a pair of scissors. What you'd find that although the avatar was correctly configured, because the legs in the T-pose have now been sort of opened out from one another, that when the walking animation plays, the character's legs will be out in the walking pose. They'll be too far apart. And if you ever see any of the animations playing weird, then just click this configure button and just make sure that the character is in a T-pose, and if not, you'll see in a minute we can manually configure it to be in one. So I'm going to click configure here, even though it's set up correctly, just so we can see what happens when we click it. And what Unity is going to ask me to do now is it's going to ask me to save this scene if I've made any changes. And the reason it's asking me to do this is in order to configure the avatar, what Unity is going to do is create a new temporary scene. And in that scene is going to be this character with its bone hierarchy on display. So it needs a scene that is empty that it can use for this purpose, so that we can manipulate its joints in the scene view. So I'm going to click save to save this scene off, and then you'll see this temporary scene be created. There you go. And in the scene view, you can now see my character, my policeman character, and it's also highlighted all of the transforms in the bone hierarchy. And you can see in the hierarchy view now that we have the ability to click on each one, and if we want, rotate it and position it. Now, we don't need to make any changes to this because it is perfectly in the T-pose. But if it were not in the T-pose, then we could just manipulate the joints so that it was. And you're going to see me doing something similar to that with some of Mixamo's animations in a moment. And on the right hand side of the screen we get to see the humanoid avatar definition, and we can click on any bone in the hierarchy to select it, or we can click on the sort of simplified node representation in the avatar. And you'll notice that underneath the diagram of the avatar we have slots that allow us to drag transforms in to let Unity know which bones in our hierarchy should be mapped to the avatar's more simplified body part definitions. And you can see here that Unity has automatically recognized that this is a humanoid rig and has automatically assigned all the correct bones. It knows that this is the hip bone, so it's identified that transform and it's assigned it to the hips slot of the avatar. And you may find sometimes Unity doesn't quite get this right if the hierarchy is not a standard hierarchy. I think there was one of the assets that I imported of a doctor that I think Darren sort of turned into a zombie by adjusting its textures. It wasn't walking correctly, and when I opened up its avatar, it had got a little bit mixed up around the feet, and it was assigning the wrong bone to the foot. In fact, I think it was assigning no bones to the feet. So I just had to configure, like I've done now, find the feet in the hierarchy, and then just, where are the feet in this hierarchy? There you go. So right foot. And then I just was able to drag that over and drop it into the right slot like so. But there's no need to do that here. Unity has automatically identified all of the body parts that it needs. It's assigned them to the avatar slots, and this character is now ready to have any animation played on it that has also been configured as a humanoid animation, and therefore has its own humanoid avatar. Now if you look in the bone list, you'll see some of them have this dotted surround, and these are optional bones, which means that you can still create a humanoid avatar even if these are missing, but the ones that have a solid surround are the bones that must exist. It will absolutely fail to create a humanoid avatar, and it will fail to be a humanoid rig if you do not have all of these mandatory slots assigned valid bones. And sometimes you might import a rig that isn't in the T-pose, even though Unity is able to find all of the body parts and correctly set up the avatar. Like I said a moment ago, Unity really needs the hierarchy to be in the T-pose because all of the animation data is relative to that pose. So if it's not in a T-pose to begin with, then when those animations play, the offsets are going to be wrong, and like I said, we could have a situation where the legs are going out too wide when it walks, or the arms are not going up enough when he strides. Like I said, if all the bones have been mapped, you can force it into a T-pose by, from the pose drop down, clicking Enforce T-pose. like so. Now nothing happened here because this is already in a T-pose, but if it wasn't, you would see the hierarchy would be snapped into a T-pose, and then that would fix any problems that you were seeing during animations. Now these are all the main ones that are needed, but you'll also notice that there are additional bones that you can set up for the head. Now the only mandatory one here is the head bone, obviously, but you can also apply a neck, which we've done here, and there's also optional ones if they exist, which they don't in this hierarchy, for like the left eye, the right eye, and the jaw. And then you have the left hand. These are all optional, the fingers, although they have all been assigned because they exist in the hierarchy. So if you've got any animations that do sort of hand animations, you would definitely want these bones to be assigned. If they're not, then the hand animation will have no effect on the hand itself. And then of course you've got the right hand as well. Now at any point you could start from a completely clear mapping. If I just go back to body part, drop down mapping and do clear, you can now see that all of the bones have been unassigned, and I could then manually assign the bones myself. Not something I would particularly want to do, and not something I've ever had the need to do. But don't worry if you do this by accident. You can also choose auto map, and that will automatically perform the process that Unity first performed when we said we wanted a humanoid avatar. It analyzes the hierarchy, finds all the bones, and assigns them to the correct slots. We're pretty much done. Our avatar is set up and ready to go. And you can test out how it's animating by clicking the Muscles and Settings tab. I have to click Apply because I've made some changes. And this allows us to try out the range of motion. So if we wish, we can see what the body moves like by performing a bend in the spine, or a left-right bend in the spine, or a twist, or we can try see what the head looks like nodding, or tilting, and we get a chance to see how the skinning looks. There's sliders for pretty much everything, you know, for moving the legs, so you can see how the skinning looks and the quality of it. So this is really useful, but really this is just fun to play with. So I'm just going to click Apply again. And I'm also going to click Done. Now, obviously, we've been in here a few minutes and I've been showing you around, but we've actually done nothing. So there was no reason to ever come to this window. So just to dial back a little bit, once I've pressed Done, all that was actually needed to change this character to a humanoid rig that can be used by any animation that is set to be humanoid is we just had to change it to humanoid and click Apply. Remember, just to remind you, we had it on generic, and then we just set it to humanoid, we clicked Apply, the little tick box came up, and everything was ready to go. Now, in this particular file, in fact in all of our character files, you'll see that we have this single animation clip created called mixamo.com. And it's just a single frame animation. We can see if I select it, mixamo.com, in the clips list, you'll see it has just one frame. Start frame is 0, end frame is 1. And we don't need that, do we? We don't need this mixamo.com animation clip being created. So what I'm going to do is I'm just going to remove it by clicking that minus sign. And you can see now the animation is gone. I click Apply and the animation clip is now gone from that list. No point having assets in our project that we're never going to use. But of course our rig is still perfectly intact. We just threw away the animation data. So what I'm going to do now is I'm going to multi-select all of my characters, okay? And I'm going to set them all to humanoid in one go. And then I'm going to click Apply. This might take a second or two because it's building the humanoid avatars for all of these files in one go. And then I'm just going to click through them all and just make sure that I have that little tick in place next to the configure button for each of my files. And fortunately, because Mixamo do actually put the hierarchy in a correct T-pose for all of their character files, Unity was able to identify the rigs as humanoid. Even that Zombie 1 rig, which we know wasn't the same rig as Jill or Derek or Cop Zombie, it's still been able to identify all of the bones. And if I click the configure button to look at Zombie 1's rig, we'll see those familiar bone names when we were looking at them earlier on. See, it's in a T-pose, and we can see it automatically identified that the hips bone was called Zombie Hips, and it assigned it to this slot, and Zombie Spine, Zombie Spine 1, etc, etc. So that's it now. All of our characters have now been configured as humanoid avatars. Now the only thing I'm going to try and do, if it will allow me to do this, is I will select all of those other characters. Nope, I'm going to go through all of my characters, and I'm just going to remove that animation clip that we didn't need. This is just me being sort of obsessed with not having assets lying around that I don't need, because you do find generally when you're importing lots of third-party assets that your project does fill up with lots and lots of stuff that you're never going to use. Now, it's not a problem because when you build your player, Unity doesn't embed anything in the player that you don't use in your project, but I still like to get rid of this stuff anyway, even though it's doing me no harm and it will never be used. The only way this animation clip would ever be used on any of these models is if I allowed it to be imported as an animation clip, and then I actually dragged an instance of it into the animation state machine. And like I said, we're going to be talking about building animation controllers later. Nearly there. Talk amongst yourselves. Did you see the game last night? What game? I don't know. Pretending I'm a sportsman. Far from it. Okay, there you go. So we've cleaned up our assets now, and all of our characters should now play any animations that are set to be humanoid rigs. So let's now go over to our animations and test that out, because, and this is really unfortunate, you're going to see a problem which I haven't encountered ever until this tutorial, where I downloaded these animation files from Mixamo. Because when I actually built Dead Earth, I actually downloaded a pack. I paid for a pack of Mixamo animations because they didn't used to be free. And I bought them off the Unity Asset Store, and they actually came in already pre-configured and ready to use. So in that particular case, I didn't have a problem with them, and they were all set up using the correct avatars. But you're going to see in a moment when we go and look at the animations that when we download an animation FBX file from Mixamo, the hierarchy inside the animation file is not actually in a correct T-pose, and this is going to cause us some problems. Now, it's going to turn out to be a very simple and quick fix, but it's unfortunate that if this is your first introduction to Mechanim, that you're going to encounter a horrible little problem like this, because this is not typical at all. I have imported hundreds of characters and animations into Unity, and I've never had this problem. Pretty much I do exactly what you've just done. For every character and every zombie, I just drag it in, I click rig, I click humanoid, I click apply, and bang, we're in and we're done. But with these free Mixamo animations, we're going to need to do a little bit of jiggery pokery to get things to play nicely. So to demonstrate the very rare problem that we seem to have with these Mixamo animations, I'm going to go to the Mixamo animations folder inside my animations folder, and I think I'll just start at the very bottom animation called Jill at zombie_walk, because I think we've seen this walk animation a few times in the last lesson. We know it looked pretty good. Now, it's currently being imported as a generic rig, and we know that when we had Jill set as a generic rig as well, they played nicely together, and we saw Jill using this animation to walk, but we saw that it didn't used to work with Zombie 1 because that rig wasn't the same as the rig used by the zombie walk. So of course what we wish to do with this animation, and in fact we'll do it with all of our animations in a minute, is we wish to set them to be humanoid rigs, and that way this animation will have a humanoid avatar created for it based on its bone hierarchy. And then using that humanoid avatar, it can then talk to the humanoid avatar of any one of our humanoid characters, and we'll be able to animate any character that we have in our scene, because remember, it's those avatars that talk to each other. So under normal circumstances, and in almost every single case that I've ever done this before with the hundreds of characters and animations that I've imported, all I would have to do is exactly what I did when I converted my characters into humanoid characters. I would just change the animation type from generic to humanoid and click apply. And as you can see, the little tick box has shown up, which tells me, although in this case slightly misleadingly, that the avatar has been successfully created and everything is good. However, if I preview this animation, and as you can see at the moment it's just using Unity's default preview mesh, you'll see that there's something wrong with the legs. It's not bending at the knee joint. So let me press play. That's not how those legs are supposed to look. Something is wrong there. And in a way, it's kind of good that this has happened, even though it's a shame it's happened so soon, because this is going to give us a little bit of experience getting around problems like this. So when I first saw this happening to the legs, My immediate thought was, what's going on here? It must be that the avatar has been set up incorrectly, or some of the bones haven't been assigned. In fact, that's not the case. If I go to the rig page of this animation and I click on the configure button, you can see a few things happening. We can see that the character is not in a T-pose, and in fact Unity is telling us the character is not in a T-pose, and it's telling us the bones that it has a problem with. And if you look at the bone assignments, we can see they were all correctly identified and assigned by Unity, and that's why the avatar didn't give us a little cross, it gave us a tick, because the avatar has been created successfully. But the pose that Mixamo put in this file for the rig was not the T-pose. And Unity is making us aware of this. Now, one of the things that we can do, like I said, to try and diagnose this problem, and this works most of the time, is we go down to the pose button. And because Unity did correctly identify all the bones, we can do enforce T-pose and click that. And this has correctly just moved and rotated the shoulder bones a little bit to get rid of those errors. However, we can see that this hasn't fixed the problem. Those legs are not in a T-pose at all. Look at them. They're bent, they're jagged, the toes are pointed, and this is the problem. Now, even though I've enforced the T-pose, if I click apply and then done, you'll notice if I go back and preview the animation again, the arms are a little bit better, but the legs are still absolutely foobarred, for lack of a better word. And this is because in this particular situation, the hierarchy is not in the T-pose, and this is a fault of Mixamo. Now, to be fair to Mixamo, you will also recall that when we downloaded our animations from Mixamo, inside that zip file was also a copy of the Jill character, and we know that the Jill character does correctly have its hierarchy in the T-pose because we've already created a humanoid avatar for it. So I think Mixamo's take on this, and the reason why they bundled that character with it, is that they expect you to reuse the avatar that we created for Jill for all of our animations. And in fact, that's what we're going to be doing in a moment, and that's what that copy avatar from another model option was for when we were creating our humanoid avatar. But we'll see us doing that in a moment. But still, it's a pain. This is not normally how animations come in. You should always see the hierarchy in the T-pose. You shouldn't be reliant on another model's avatar in order to get your humanoid animations to work correctly. However, just to show you that this is simply down to the T-pose, before I fix this in the more efficient way, one way that we could do this is go to the rig and choose to configure the hierarchy and manually set the legs into a T-pose or as close as possible ourselves by simply selecting each bone. You can see once I move bones, Unity lights them red when it says, hang on a minute, this is definitely not a T-pose. So then I have to kind of doing the best I can with this limited view. I should probably be in ISO view here, but I'm not trying to get it perfect because this is not the method I'm going to use anyway. I don't know, do I need the feet up or down? I can't quite remember. And to be honest guys, I hadn't used Mechanim really for anything since I started on Dead Earth, so it's pretty terrifying for me to be in this video trying to sound like I'm an expert on this stuff when I've only really done a few months working it myself. Okay, so I think also those legs are too far apart, so they probably need to rotate in a little bit as well. And if you push it too much, Unity will light it red, and that will be a very visual indicator that this is not a T-pose. That's not a perfect T-pose, but this is probably enough to sort out the legs animations. And it's pretty good that this has happened because it also shows you how to diagnose this problem if a certain animation is not playing correctly, and shows you how you can adjust the bones of the actual avatar and the hierarchy inside the file. So I'm going to click apply, I'm going to click done, and I think, fingers crossed, you can already see the legs are bending now. We should have a much better... Okay, yeah, I took the feet the wrong way. The legs are looking perfect now, in fact, but you can see that because I moved the feet down, he now looks like he's walking on tippy toes, so that's no problem. Let's fix that. Not quite sure what the correct orientation of these is actually supposed to be, but maybe they are supposed to be tipped down a little bit like so. Maybe, it is supposed to be on tippy toe. Does that look about right? Oh, it'll do. I'm not going to keep this anyway because there's a better way to do this. There you go, his feet are now planted on the ground. How about that? So we have just taken an animation file that had a hierarchy in a completely erroneous T-pose, and we fixed the T-pose manually so that now that animation will play correctly, or at least just like this, on any other character that is also assigned a humanoid avatar. Now the problem is this same problem I've noticed in pretty much every single one of our animation files, and I don't know about you, but I don't want to spend the next 20-30 minutes going through every one of these files and manually configuring the avatar. Now it turns out that there is a much better and quicker way that we can diagnose this problem for all of our animations, because although these animations haven't had a correctly positioned T-pose for its hierarchy embedded in them, all of the models, the character files that we downloaded from Mixamo have. Now we also know that all of these animations were originally designed to work with the Jill character model, the Jill rig. Therefore we do have a copy of the Jill rig in a correct T-pose, which is in the Jill character file itself. So there's Jill. Let's just select a rig and choose configure. Looks like a pretty good T-pose to me. No errors from Unity, feet close together, no bent knees. Perfect. And you'll find that the T-poses in all of Mixamo's character files are correct. It's just a real shame that they don't give you them correct inside the actual animation files. So what we can do is we can reuse Jill's avatar with all of those animation files, because remember, those animation files which were designed to work with Jill's rig will have an identical avatar created for it anyway, because the hierarchy in each of those animation files has the exact same bones and bone names as the Jill character. So even if we generated a separate avatar for each of those animations, if we examined the avatar, it would look identical to Jill's. So we're just going to reuse Jill's for those animations. So in order to do that, all we have to do is we have to go back up to our animation file. We have to click, let's say, walk. We'll do them one at a time for now. Oops. Let me just say done here. Then go back to the animation, click walk. And what we'll do instead is, instead of saying create an avatar from this model, we'll say copy from another avatar. And when we do this, we get a little file selector come up, which allows us to choose an avatar asset that is already in our project. So we'll just click the file picker, and there is Jill's avatar there, Jill 2's avatar, and we'll use that one. Click apply. And if we open up the asset in the project view now, you'll notice that unlike the other ones that have an avatar asset, this now doesn't even have its own avatar asset, because it's going to use Jill's. And all of these animations will work with Jill's avatar, hence the reason the naming convention is Jill at the beginning of their names. So I'm guessing this is why Mixamo supplied us with the Jill character when we downloaded these animations, because it knew of this problem and was thinking, we're going to give you this character because this contains the correct T-pose that should be used to generate the humanoid avatar for these files. So I've got to click update, then click apply. Not always in that order, but if you see the update button, just click it, and then click on the animations tab. Remember, we're looking at the zombie walk animation now, and there you go, a perfect walk animation. But here's the cool thing: do you remember that this walk animation would work with Jill and it would work with Derek, but it wouldn't work with Zombie 1? But of course, Zombie 1 has now been created as a humanoid rig with a humanoid avatar. So this animation should work with any of our characters. But let's try it with Zombie 1, because we know this one definitely broke when we tried to use it. Ta-da! Oh boy, you gotta love retargeting, right? Oh, beautiful. Let's try it on something else. I don't think Mortimer worked either. Well, you can see as soon as you drag them in, they all work. And Girl Scout. Congratulations, we have just imported a load of animations and a load of characters, and we have performed human retargeting to get all of our animations working on all of our characters. Oh, but wait a minute, I've jumped the gun. I've now got to do the same thing for all of those other animations. I need to tell them all to use Jill's avatar. Now hopefully it will let me do this whilst mass selecting. Looks like it will. So with all of those other animations selected, instead of using create from this model, I'm going to choose to set as humanoid. Then I'm going to choose to copy the avatar from another model. Then I'm going to click on the avatar picker. I'm going to choose Jill's avatar from the avatar list. Click apply. Might have to wait a minute while it updates all of those animations. And we should be in good stead. So let's try this out. So let's try the crawling animation. Let's try the biting animation. In fact, let's just test it fully. Let's copy over Zombie 1 because we actually know that Zombie 1 did not work with any of these animations. So that's the best test. Let's try the attack. Ooh, I dragged over biting by mistake. Now let's try the attack. Oh, what am I doing? Sorry about that. Now let's try the... I was dragging an animation into another animations preview window. What a knob. Ugh. Oh yeah. Running. This is the mutant run. Then we should have a zombie run as well, which is a slightly different run. And a headbutt. Bosh! Have some of that. Okay guys, how about that? Now we have a set of zombie animations that will work with all of our characters, and all of our Mixamo stuff is set up and ready to be used. And all of these animation clips will in the next lesson be sort of dragged into an animation controller and will be used to animate zombies in our scene in a really nice organized state machine. So let's just have a little bit more experience. I'm going to take you to the asset store. I'm going to show you an asset that is free of a kind of zombie mutant monster thing, and we'll download that and we'll just check that the same technique works with that as well. So I'm going to open up the asset store by going to the window menu and choosing asset store from that menu. That's going to open up the asset store on its home page, but the window is going to be docked and I want a little bit more room so I can see what's going on. So I'm going to undock it so I've got more space to play with. And the first thing I want to draw your attention to is a company called Motion Capture Online. So I'll type that in, press enter, and this is a company that specializes in animations. Now they have this really cool, although very expensive pack called Mocap Animation Pack Zombie. Now the 4-pack is €107, but it contains 113 really high quality zombie animations. So that might be worth a one-time payment to really bolster up your animation library. You know, you pay once, you got them forever. If that's a little bit steep, there is also a basic version of the package, which is €53, which contains, how many does it say here? 43 animations. So it's just a smaller selection, but would give us some nice variants for walking and crawling and things like that. However, they also have a free version of the pack, which contains this model here, which we're really not interested in, but it does contain 4 animations, which doesn't sound a lot, but it has a nice idle, a nice variation for a zombie walk, and also a nice variation for a zombie crawl. So it's well worth downloading this pack, even if all it's going to do is add 3 animations to our library. I build up most of my library that way by just scanning the asset store and finding a pack here and there that might not have a very nice model, and I have no intention of using the model, but perhaps comes with some nice animations. And likewise, you might download a pack where the animations are horrible and you throw them away and don't use them, but you really like the model. Now in this case, it's a good model, but it doesn't suit our game. So we're going to import this pack, and all we're interested in is the animations, and of those animations, probably only 3 of them. Just don't be put off by the screenshots, because you can find assets that use really rubbish models, where perhaps the person that developed that asset wasn't a modeler, but he was an animator, and then you download that pack, think it's going to be rubbish, but the animations are really high quality, and also vice versa with models versus animations. So I'm going to import this into our current project, and then we're going to see what's involved in using the animations for this model with our Mixamo characters. So I'm going to click import. I'm going to close down the asset store. Should see a folder be created in our assets folder. There it is, Zombie 013, and there's a couple of subfolders. There's one that contains a PDF with the manual and things like that, and then it's the FBX folder that we're interested in. And in the FBX folder is the model itself called Motus Man. There he is, dun, 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 in his T-pose. There's also an animation folder, and both the animation and the model all come in with a generic rig type. So at the moment, these animations will literally only work on our Motus Man model. There's the crawl. Pretty good, isn't it? Let's try the walk. Yeah, I like that one. That makes a very nice variation. And there's also an idle. Looks good to me. But at the moment, they all use generic rigs, and so too does the model. So let's first of all convert the model over, just for a proof of concept. So we'll select the Motus Man model, and we'll set its rig from generic to humanoid. And we'll leave it on create from this model, which we know means that the hierarchy in its T-pose in this file will be used for configuring the avatar. So I click apply, and we can see there's the little tick box there. So if I click configure, just check we've got no errors and all the bones look like they've assigned correctly, which they have. So I click done, and that's it. Motus Man has now been converted into a humanoid animation type with its own humanoid avatar. And now any of those Mixamo animations that we've also targeted to be humanoid will work on Motus Man. So let's try that out. Let's choose one of our animations, such as the zombie walk animation. Now, if Motus Man doesn't show up in the preview window, if you're trying this yourself straight away, then with the animation still selected and the animation tab selected, click back over to the folder that Motus Man is in and just drag and drop him into the hierarchy. I didn't have that problem there, but if you do, just remember to drag the model back over. And there you go. Playing absolutely fine on Motus Man. Funnily enough though, the animations that came with Motus Man will no longer play on the Motus Man model because they are still generic rigs, whereas Motus Man is now a humanoid rig. And if you don't believe me, let's just choose the zombie walk that came with Motus Man, and look. Or the zombie idol. It has no idea what to do with that model. So we need to set these animations up so that they're configured to use humanoid rigs as well. Now remember, each one of these animations has a rig in it. So when we convert it to a humanoid rig, we've got a choice, unlike we really had before because of the problematic rig that was inside the animation files from Mixamo. The rigs that are inside these animations are perfectly fine. So if we want, we can just tell each one of these files to generate its own avatar. Or we can say, actually, just use the avatar that was created for Motus Man, because these animations were originally designed for Motus Man. We know their rigs match. So what are we going to do? I think because with the Mixamo situation, we were forced to share the avatar of Jill, I think this time we'll create a unique avatar for each of our animation files just to check that works too. So I've multi-selected those 4 animation files. I've selected humanoid, but instead of saying copy from other avatar, I've just said create an avatar from the rig that's in this model. I click apply, and after a short pause, we should be done. And if I select, let me say, the zombie walk that comes with this pack, go over to the animation window, we can see Motus Man is currently selected in the preview window. You can see it's a pretty good animation. We also have an idle. Pretty good. Pretty good. Oh, by the way, when you're previewing anything, you've actually got in the top right corner of the preview window a slider bar where you can control the speed of the animation. So I can speed it up, see what it looks like playing back at twice the speed, or slow it down. I've never really had to use that, to be honest, for anything other than fun. And the other animation we've got, which we may use, is the crawl animation. And then we have this animation here, which we probably won't use, as you'll see later on. But this is a transition animation that takes it from a stand to a walk. So it's the sort of thing, if you were doing a state machine, you could have the idle animation, and then when we detect that the character is now moving, we transition into this stand to walk animation for one cycle, and then we transition from that into the walk animation. So it provides us with a custom mocap recording to transition the zombie or the character from an idle phase into a walking phase if we wish to use it. The other option is, and this is the one we'll probably use, is we'll just use Mechanim state machines and animation blending to blend from the idle clip into the walking clip, which probably won't look as good, but it will give us slightly more control, and we're not going to have one of these transition animations for all of our various walks and idle cycles anyway, so we're going to have to come up with a system that works for all the animations that we have. So we're not really going to use that animation. So you can see if I chose to change my mind and say that we want to not generate a unique avatar for each of these files, but instead just share the avatar that was made for the Motus model, then we could do that too. We could go to the rig again, with all of the animation files selected, and we could choose copy from other avatar, go to the avatar picker, and there should be an avatar in there called Motus. There it is, Motus Man V2 avatar. And then click apply. Oh, very important, I press update, then apply. Never figured out why that button shows sometimes and why it doesn't others. Okay, now let's see what this looks like. So I'll press play and we can see that these animations still work on Motus Man or indeed any humanoid rig, even though they haven't got their own unique avatars, and that's because they're sharing the avatar of Motus Man, which is perfectly compatible with the original rig stored in all of these files. So I guess the final thing for us to test is that these animations correctly animate our Mixamo characters. So which one should we try? Well, let's try our walk one, like so. And then I'm going to go to my Mixamo characters folder, and I'm going to drag one of my Mixamo characters into the preview window of that zombie walk animation that we just retargeted. And yeah, look at that, works fine. Let's try it with White Clown, or with Girl Scout. Okay, so there you go. We saw how to bring in another asset. We saw how, if we wanted to, we could retarget Mixamo's animations to work with the Motus Man model. Now, we don't want to do that, but what we were interested in was the other thing, which was taking the animations in that file and getting them to be humanoid animations that work with all of our humanoid characters. So I think what I'm going to do is I'm going to do a little bit of rearranging here. I'm going to create a new folder in my animations folder, and I'm going to call this Motion Capture Online, which is the company that we got these from. And then I think I'm going to drag all of that stuff in there instead of this Zombie 01 folder. And then I think I'll delete that original Zombie 01 folder from my root. And then in that Motion Capture folder, what have we got in images? Oh yeah, it looks like it's just all the instructions. We don't need those. We're experts now, I tell you. So let's get rid of that. Docs folder, we don't need that. And then in the FBX folder, I'm going to keep Motus Man around. If I wanted to delete Motus Man, then I would need to be wary of the fact that I've currently set my animations to use Motus Man's avatar, and then we would have a missing avatar. So for that reason, I think I am going to set all of those animations back to have their own copy of the avatar. So I'm going to say create from this model, press apply, and then I should be able to delete the Motus Man model and folder from my project, and I can probably delete all of the Motus Man textures and materials as well. In fact, when it comes down to it, then I don't really need an animation folder. I can just drag those animations right out of there into the motion capture folder, like so. And then I think I can delete all of the subfolders and stuff and just have those animations. Now, because Motus Man is gone and we deleted all of the textures and the materials that were being used by this file just to show its sort of internal contents, we're getting this pink placeholdery thing. Doesn't matter. When we actually want to play the animation, we can just assign any of our character models to it, like so. So all of that stuff now that I downloaded from Motion Capture Online is really just boiling down to a single folder called Motion Capture Online in my animations folder with those 4 FBX files imported in there. So very quickly, before we go, I will give you one more free asset to play with. So if you go to the asset store once again, and this time type in the search bar PXL, short for pixel, tiger, all as one word. And you'll see there is this zombie model. It comes with some animations, but as you'll see in a moment, they're not really any good for us. They're not particularly high quality, but the model is really, really good. So let's import that into our project as well. Click import, close down the asset store. And here it is. It's just in a folder called zombie. So let's go into the model folder and see what's in there. And now the way that these have come in is slightly different again. We have the walk animation, which also contains the mesh. You can see there's all the mesh parts, and then there's the avatar and the walk clip. But these other animations don't contain the mesh. Okay, so the mesh is only actually in the very first file that we imported. So if you look at these animations, they're not very good. For starters, this one has no root motion. It's an in-place animation, which is why he isn't walking forward. He's just sliding on the spot. So that is no good to us whatsoever. But we do want to keep the mesh. So if we wanted to keep the mesh and just get rid of the animation data, then we could just untick import animation, click apply. And we do, of course, want this rig to be set to humanoid. But I'm not going to do it now. I'm going to leave it on generic for the time being. Okay, I'm just going to do revert, just so we can preview the rest of the animations that came with this set. So this is one called right for. Don't think we want that, do you? Or that terrible animation. Or back for. Terrible animation. What about an attack? Ooh, go away. Ooh, Could call that Camp Zombie. Okay, so none of those animations are really any good whatsoever. So I think what we'll do is we'll get rid of them. We want to keep the walk animation file because that is the file that contains the mesh. But we've already told Unity we don't want to import the animations for that file. So we're just interested in the rig and the model that's in it. So the rig is currently set to be generic. Let's set it to be a humanoid rig. Click apply. We've got a little tick mark which tells us everything went fine, although that doesn't look like a T-pose to me, so looks like the legs should be a little closer together. Maybe I'll just give that a quick rotate like that. Yeah, then click done. And that's it. He's now humanoid, which basically means if we pick any of our Mixamo animations, such as our running animation. Remember, I have to go to the animations tab. There's what it looks like with Jill. Let's see what it looks like with this new dude. So I drag over the Z at walk file. There he is, running in his full glory. And of course, this should also work on those animation files that we downloaded from Motion Capture Online as well. So let's have a look at that walk file from there. Yeah, works fine. So there you go. Now we've seen how to bring down an asset that contained animations that we didn't want to keep, but target the model itself to use animations that we already have, because this model isn't too bad. It'll look a lot better when we put some decent materials on it. So with the hard work done for this lesson, let's just wind down over the last few minutes while I show you some of the assets that I purchased to bolster my animation and character library for the creation of Dead Earth. Now, of course, you don't need to buy any of these characters. The techniques that we've learned about today can be applied to all characters and all rigs and all animations, but I'm just showing you what I bought, and you may be interested in some of these, and you won't need to purchase these yourself in order to, follow on studying with me in this channel. So the first pack I'd like to feature is one that I purchased called Zombie Motion, the publisher Polygon Craft. This asset is composed of 47 high quality motion captured animations. I can't remember whether it includes a model or not. I guess it does include a rough character. And you can see the animations playing on the screen now. Don't be put off by the low poly models. Remember, it's the animations we're looking at here. This is €48 approximately, and I found that a lot of these were very usable, and they had root motion, and there were some unusual animations in here as well, such as zombies clinging to fences, or a zombie having his foot trapped down a drain or under a car wheel. So this was definitely worth the money, I thought. Next up is a nice cheap little animation library for €16 by the publisher Morrow Motion, and it's called Zombie Mocap. And I like these animations. They all have root motion in them, and they provide a nice variation for things like idols, attacks, and more importantly for turning left and right, because that was something that I found I had a shortage of. when I downloaded my zombie turn left and zombie turn right from Mixamo, it was a very kind of aggressive turn, almost like a seeking behavior. And that was really great for the zombies in my game that look alert and run at you. But for other zombies that look like they can barely stand up straight and are walking almost as if they're drunk, it doesn't look right if when they need to turn around, they suddenly go into this really aggressive pose, like all of a sudden they've become more sentient just for the turning animation. So in here I think there's some nice kind of sway turns. And here's a really nice addition to your animation library by the publisher T-Pose. It's called Zombie 1 Mechanism. This contains the model that you see on the screen as well, which actually looks pretty good in the game. They come with high-res textures and 44 zombie animations. I think it even includes some blend shapes for facial animations. So this is definitely worth a look. Publisher T-Pose, the name Zombie 1 Mechanism. And then we have a very cheap asset here for just €5.50 approximately, called Melty Zombie by the publisher M.I. It contains the model that you see on the screen, which honestly isn't terrifically high quality. Might be good for some background monsters that maybe you don't get too close to. But there are 15 animations included. Not all of them are great, but some of them are. So it's a case of sorting the wheat from the chaff, so to speak, when going through the animations that you get with this. Like I said, it comes with 15 animations. It's €5, publisher M.I, and it's called Melty Zombie. A publisher called Code This Lab on the asset store has quite a few zombie suitable assets. This is where you will no doubt recognize if you've seen the Dead Earth trailer, where I got my mechanic from, as this dude pops up in all of my videos. But there are also some other really cool ones as well, such as Zombie Female, Zombie Maid, Zombie Policeman. So check out Code This Lab, because I haven't covered all of the various zombie models that they've got available. But if you just type Code This Lab into the asset store, then you'll be able to be taken to their page and you'll be able to see all of the assets that they've got available. They're not all zombie assets, but a lot of them are. Also a lot of sport assets, just in case you're in the market for making a soccer game. And then if you visit Arabian Art Studios, or just type in Fat Zombie, at the time of me recording this video they only had one asset, which was Fat Zombie. It's a little bit pricey, whereas Code This Lab's assets are normally around about €32. Fat Zombie is €59, but I think you'll agree it is actually a higher quality. And it looks like it's got several LOD levels, and I think it'd be pretty terrifying with that big dude running at you. And to be complete, although we've looked at this already, I will include it in this lineup just to remind you that we have that really cool animation library, admittedly a bit expensive, from Motion Capture Online. Remember, that was the one we downloaded, the sample pack with the 4 animations. But they're good animations, and this pack has 113 in, so it's going to be pretty much everything you want in there. It is pricey, €107, but I'm going to see if I can get hold of Game Institute's credit card and treat myself. Okay guys, so that ends up this lesson. You have everything you need now if you see any assets on the asset store that are humanoid models to import them and retarget them to be humanoids. Now, we didn't get around to talking what a generic avatar is. Basically, a generic avatar is just what you use if it's not a humanoid avatar. The only reason we need a generic avatar is because Unity's animation system uses an animator component, and that animator component needs to have a few things to link it to the character, and one of them is the avatar, because it's the avatar that the animation controller animates, and the other thing it needs is an animation controller. So you can't really do any configuration with a generic avatar. It is pretty much what it is, and we'll look at some of the things you can do with avatars a little bit later, as and when we need to use them. But if you import a character that isn't humanoid and you want to use mechanism, you want root motion, then you just have to set it to be a generic avatar. But do bear in mind that those animations will only play on other rigs if they have exactly the same generic avatar, if they have the exact same bone layout and bone names. But we'll see all that being used later, because I'm pretty sure I'm going to import some animals into my game as well and have some feral dogs running around. So that'll give us a chance to use generic avatars. So thanks for listening, guys. I'll see you next time. Bye now.